will not bore you much. We'll have a recap session only for say 40 minutes or half an hour. After that, I'll give some challenges where you can sit and solve them. It will be very interesting. Okay. So don't worry about only ANN recapping today. Okay. Last semester, what did we do in embedded learning? ANN and CNN. How did we develop ANN and CNN models? From scratch. What do you mean by from scratch? Did we use TensorFlow, PyTorch or any other modules for ANN? So what do you mean by from scratch? No discussions please. Discussions involving here, not discussions among yourself. Yes. What do you mean by developing ANN models from scratch? Each function was defined from scratch. Means, what are those functions that we have defined? So you have three major things that we do when we talk about ANN. What are they? Forward propagation, loss calculation, backward propagation. So how did we develop this from scratch? So we have some particular formulas for each and every step, right? So what do we do in forward propagation? So how does ANN works basically? How many of you are new here? Apart from last PS batch, how many of you are new? Okay. Okay. Yeah. So how does ANN work? See, let's keep the class interactive so that you'll not sleep and you'll not get bored. Okay, because all of us know all these concepts which we have studied. This is just a brush up session. Okay. So how does ANN work? What are ANNs? Artificial neural networks. Why do we use them over machine learning models? For better accuracy. In what sense? Model predictions. Okay, is that the only reason? Features are extracted automatically. Very good. When we talk about deep learning models, feature extraction is done automatically. Whereas when we go for machine learning models, human intervention is required when we talk about feature extraction. This is one thing. Second point, of course, but better accuracy. Third thing, can ML models handle huge data? Can ML models handle huge data? No. Okay. So there are so many disadvantages when we talk about basic machine learning models. They can't handle with large data, and then of course they can't understand the patterns or insights of the data in depth. Okay. So for that reason, to understand the patterns or insights of the data clearly, to get good accuracy, we will be going for deep learning models. So what is the major difference between the architecture of machine learning models and deep learning models? Deep learning models involves what? Neural networks. So how does a neural network look like? So we have layers, right? So how many layers? Three. What are they? Input, hidden and output layer. Okay. So how many neurons in each layer depends on what? Number of neurons in the input layer depends upon features. Number of neurons in the hidden layer is up to you. You can program it as per your this thing. So what will happen if I increase the number of neurons in the hidden layers? More detailed the feature extraction runs if I increase more layers, right? So what do you mean by more detailed feature extraction? Understanding the complex patterns in the data. Okay. If suppose I give a complete picture of this auditorium and say identify ASHA. If it is ASHA standing separately like this and a picture is clicked from that angle, ASHA will be identified easily. But if I sit one amongst you then somewhere in between and identify ASHA, I have to add more layers. Because I have to identify every person in detail and then check for ASHA there. Okay. So depending on the type of data that we have, we add more number of layers. Are you getting my point? If ASHA is standing here separately, identifying her easy, so I design a neural network with only one layer. If I want to identify somebody sitting in between the entire class, I have to add more layers because I have to do the search operation more. Yes? So for this reason, we add more number of layers. This is what we have seen. Okay? So how does neural network function? How does ANN function? So we have this forward propagation, we have loss calculation, we have backward propagation. What is this forward propagation? What do we do? First we take the input, which would be fed to the input layer. Okay. Now for these inputs we add what? We multiply them with the weights, add a bias term to that. So such that we generate a transfer function, right? So what is a transfer function defined? How is a transfer function defined as? Summation of Wx plus B. What is this W? Weights. What is this X? The input. What is this B? The bias term. Why do we have to add weights? Why do we have to add weights? Why are we not processing the inputs directly? Yes? Why do we add weights? If suppose I pass the input directly, I get some output. If my output is wrong, what do? Do I change the inputs? See, I teach for you guys. You write the exam. If you fail, will I not continue teaching you guys? I have to make some improvements on you by adding different methodologies. For that reason, we add what? Weights. My teaching methodology would be different depending upon your performance. If you're performing well for the first instant, I feel my teaching is okay and I carry on like this. So I can't change the inputs. For the same set of students, I have to improve the performance by doing some other operations. So I can't make some operations on the input, right? So what do? We add some weights, multiply those weights with the inputs, and if I don't get proper inputs, what do? I don't change the students, I don't change the input. I change my methodology, that is the weights, and check for the functionality. Okay. Now after I go for transfer function, what do? We apply this to the activation functions. Why do we use activation functions? To introduce non-linearity to the model such that the model will understand the patterns and try to predict your results, right? So what are the 4 activation functions that we have seen? Sigmoid, tan H, ReLU, softmax. Okay. Now where do we apply these activation functions? In 2 places. One is in the hidden layer, one is in the output layer. Please remember this point, I'll come back to you again. So we have seen 4 activation functions: ReLU, tan H, sigmoid, softmax. When do we use ReLU? Or when and where do we use ReLU? For regression or classification in the hidden layers, we will be using what? ReLU. This is what we have seen. And for the output layer, which activation function do we use? For regression models, do we use any activation function in the output? No, because for regression I need continuous values. So remember, regression models will use ReLU in the hidden layers, no activation function in the output layer because I want to extract continuous values as they are. When I talk about classification, we use same ReLU in the hidden layers, that is what we have seen, and then either sigmoid or softmax in the output layers. When do we use sigmoid and when do we use softmax? Sigmoid for 0 and 1, that is binary classification. If I have multi-class classification, I predict my output based on probabilities, for which I have to go for softmax. This is what we have seen in the last semester, right? So we have 2 different types of tasks. One is classification, second one is regression. Again in classification we have problems which are classified on binary classification or multiple. What is this regression and classification? If the output values is continuous values, we use regression. If the output variable has discrete values, we will be using classification. Again in discrete, if it is binary, only 2 classes, binary class, multi-classes. Okay. So this is step 1, which is forward propagation, Wx plus B, summation of Wx plus B, applying 4 activation functions on hidden layers and output layers. After this, what is step 2? Loss calculation. How many different formulas we have for loss calculation? 3. One is for what? Regression. The loss function depends upon the model. If it is regression, we either use MSE or MAE, mean square error or mean absolute error. If it is classification, again in binary classification we use binary cross entropy. For multi-class we use categorical cross entropy. This was step 2. What do we do in step 3? Backward propagation. What do you mean by backward propagation? Adjusting weights, for which we use optimizers. For which we use what? Optimizers. The basic standard optimizer is gradient descent. Other than that, we also have SGD, RMS prop, Adam. Okay, we have other, you know, optimizers for us to work with backward propagation. So what are the two optimizers that we have used in the last semester? First we have worked on gradient descent and we have also worked on Adam. Okay, we'll extend that this semester. Okay, as you were new for the last semester, we have used only two. I'll tell you what to be done in the current semester. Okay, so what does this optimizers do? Changes the weights, and again the process is repeated such that the loss function will be reduced. So how many times do we repeat this process of forward loss and backward? Till we get the reduced loss. That is, once you have the reduced loss, you will be getting good accuracy. This is what we have done in the last semester. Yes or no? Okay. So what we will be doing today is, I'll give you a challenge or a simple exercise on developing ANN from scratch, not any data set. So what we will do is, how many of you know about XOR gate? Logic gate sadukunnarga. What is this XOR gate? When both the inputs are same, that is for 0. See, let's take only 2 bits. Let's take only 2 bits. 0, A and B. Okay. So what are the 4 combinations of these 2 bits? 0, 0, 0, 1, 1, 0, 1, 1. What would be the output for these 4 bits? 1 bit output. Let's say call it as Y. So for 0, 0, 1, 1, if the inputs are same, the output would be 0. If the inputs are different, that is for 0, 1, 1, 0, the output would be 1. The formula is A bar B plus AB bar. Okay, if I take AB as inputs. Okay. Now, what I want you to do is, you have to develop ANN from scratch by designing your own data set for XOR gate. Okay. So, how do you design the data set? The input would be an array of what? 0, 0, 0, 1, 1, 0, 1, 1. Okay, 2 bit in, only 2 bit. The 2 bits will be 1, 0, 0, second time 0, 1, third time 1, 0, fourth time 1, 1. Output is only 1 bit. It will be either 0 or 1. When I give 0, 0, the output should be 0. Correct? When I give 1, 1, the output should be 0. When I give 0, 1 or 1, 0, the output should be 1. Madam, what is the big deal in this? Is the deal here? Okay. So last time we have just tried to work on developing neural networks, but we didn't see the in-depth insights of hyperparameter tuning. What is this hyperparameter tuning? What is this hyperparameter? Only we have seen learning rate. Hyperparameter tuning we have seen only learning rate. But what we are going to see, today's session will be very interesting, I'm telling you. What we will do today is, I told you one thing in the last class, or I repeated the same thing. I said, we use ReLU in the hidden layers always. But you never asked me, why do we use only ReLU? And I never told you, because I want to bring you to this session. Okay? So, I want you to check what will happen if ReLU is used in the hidden layers. I also want you to check what will happen if sigmoid is used in the hidden layers. Is that clear, everybody? So I want you to understand about one concept which is called as loss convergence. What is this? Loss convergence. I'll explain you what is loss convergence, but I want you to do the exercise and check if you are able to see that loss convergence or not. Okay. Now let me talk about loss convergence. First I do forward propagation. I get loss which is 60%. Okay. I run the step. 60 loss is huge, right? So I want to reduce this. So what do? I go for backward propagation. I update the weights and again calculate my loss. Now this time it has reduced to 61. From 63 it has reduced to 61. So even 61 is a huge loss. So I again repeat the process for another epoch, and this time I got 50. I run it again and next time I got 40. And I run it again, I got 30. I run it again and I stop where I got 20. So 20 loss means accuracy is around 80, which is okay. So what do you observe in this loss pattern? The loss is gradually getting reduced as I am running more number of epochs, which means the loss convergence is happening at a good rate. The loss is gradually reducing, which means that the model is understanding that the loss is more and it is adjusting the parameters using optimizers in such a way that the loss is reduced, which means that the model is getting trained properly. Is that clear? See, once I teach you, you get 50 marks. I am not satisfied. I again teach you and test you, you get 60 marks. Still I want improvement because I found that you are improving. When you are improving, what does that mean? You are learning. So I want more learning to happen. So I teach in depth again, and next time I get 80 marks. So I'm happy with this. Which means what? You are able to learn properly. So this is what we want our model also to get trained way in this way. So learning rate is one parameter, hyperparameter tuning. Second thing is number of epochs getting changed. What is the second hyperparameter tuning? Number of epochs. There's a clause here again. Okay, the clause is if we use very small data, is XOR gate the big data set? I have only 4 possibilities 0, 0, 0, 1, 1, 0, 1, 1. It's a simple data. Okay, for which even if you take 10,000 epochs, 20,000 epochs, 30,000 epochs also, the performance would not be much increased. I want you to observe that. So, I say, what I mean to say here is, even if you are increasing number of epochs, the performance may not be as expected if the data set is small again, because the machine is not able to understand much insights from that data. Here again we get a problem. Okay. So what is the third hyperparameter tuning? Okay. Third hyperparameter tuning is adding more number of layers. Adding what? More number of layers. And in that layers also I want to add more number of neurons in each layer again. Not just adding layers, but more number of neurons in the layers. Change ReLU instead of sigmoid and observe what? Loss convergence. Okay. And then do what? Add more number of layers, add more number of neurons in each layer also, and then observe the performance of the model. Okay, that is, the model performance depends on various parameters. One such parameter is learning rate. Change learning rate in one case, change the activation functions in the hidden layers, change the number of hidden layers, change the number of neurons in the hidden layer, and then check for the performance of the model. So that is the reason I don't want to burden you guys with big data set, lecture, modeling, 150 samples and all that. Create a simple data set, simple ANN model from scratch, and then check for different hyperparameter tuning such that your model will give good accuracy. When I say good accuracy, 0 0 ki 0 ne ravali, 1 1 ki 1 ravali, 0 1 ki 1, 1 0 ki 1. I am telling you, if you work on the basic ANN from scratch model, that is with ReLU and sigmoid, the accuracy would be around 40 to 50% only. I have done that. Okay, last night I was sitting and checking on that. We will be getting accuracy of only 50, and I'll tell you where did we go wrong. For 0 1, the result was 1. For 1 0, the result was 1. For 1 1, the result was 0. But for 0 0, the result was 1. I changed number of epochs to 10,000, 20,000, 30,000 also, but for 0 0, it is showing it as what? 1. 0 0 should be what? 0, but it was showing 1 no matter how many number of epochs I change. Okay, so for that reason, see, put this as one code. Okay, in the same notebook, you write another code where you add what? Where you add what? Sigmoid in the hidden layer, sigmoid in the output layer also. Okay, and check for the performance. In the third one, add more number of layers, more number of neurons in the hidden layers while you initialize, and then check for the performance. Okay, so, I am not yet done. So what I want you to know is how loss convergence is happening when you change the activation functions. This is okay, but I want you to tell me the reason also. Okay, let's say for ReLU the loss convergence is good, obviously good. అందుకనే we have taken ReLU. For sigmoid the loss convergence will be very poor. What do you mean by poor loss convergence? For one epoch, if the loss is 60, for the second epoch also it will be 60. For 100 epoch also it will be 59. For 10,000 epochs it will be 58. Is there any use of this? So ReLU will have good loss convergence rate, whereas sigmoid will not have. So that is the reason we use what? ReLU in the hidden layers but not sigmoid. Why ReLU? Why is that happening? Anedi you should tell me. Okay, so I'll give you clues. It is all because of two concepts which I called as vanishing gradients and exploding gradients, which I have already covered. If you remember, sit, work on that, and you have to tell me by the end of the day. Okay, why ReLU? Why sigmoid? How is ReLU giving good convergence rate and not sigmoid? Is it clear, everybody? Yes or no? So what is your task for today? Develop an ANN model from scratch for XOR gate. First exercise. Second exercise, change the activation functions in the hidden layer and output layer and check for what? Check for loss convergence. Third one, hyperparameter tuning more by changing learning rate, by adding more number of layers, and then check for the output prediction. Okay, I'll show the results very clearly. I won't show you the code. I'll show you the results such that you can sit and work on it. Okay, so before we actually go to the exercise, for those who are new or for those who didn't listen what I spoke all till now, and for those who are sleeping in the last semester, you can just listen to this at least now so that you'll be in project school this semester by performing well in the exam after the 3-week sessions. Okay, so for building ANN networks, what do we need? We need to understand how neural networks work. We need to understand about activation functions. We need to understand about loss functions, and we also need to understand about optimizers.
Yeah. So this was the simple neural network that we have seen, which has 3 layers. Okay. Yeah. So we have also seen we have 3 types of neural networks. What were they? ANN, CNN, RNN. What are ANNs? Artificial neural networks. CNN, convolutional neural networks. RNN, recurrent. So what are the 2 types of neural networks that we have seen in the last semester? ANN and CNN. When do we use ANN? When do we use CNN? When you are working on numerical data, we use ANN. When we are working on images, we use CNN. This semester, whole semester, we will be working only on RNN. So what did I tell you? When do we use RNNs? When we have text data. When we have what? Text data or sequential data. When I talk about sequential, I may have numerical sequential data. We use RNNs for processing sequential data. When I talk about sequential data, there are 3 types of sequential data. One is numerical sequential data. When I talk about numerical sequential data, it is stock price prediction. So when I talk about sequential data, I have 3 types of sequential data. One is numerical sequential data. The applications where I use numerical sequential data is stock price prediction. So I predict the stock price for tomorrow based on what? Last 1 week. Last 1 week in order. Last 1 week, January 10th, January 11th, January 2. I want it in sequence and observe whether the stock price are getting increased or decreased based on the days, like that. Okay. Weather prediction. I want to predict today's weather or tomorrow's weather based on last 1 week's weather patterns in sequence. I don't want to predict tomorrow's weather based on 25th January 2022. I don't want random data. I don't want mixed data. I want sequential data for weather prediction, stock price prediction, where the values are numerical. So your ANN will not work for numerical data. Your CNN will not work for numerical data. So we'll go for what? We'll go for what? RNNs, recurrent neural networks, for the same. This is about sequential numerical data. Secondly, I have text processing, applications like language translation, your notebook preparation, documentation, everything requires the data to be processed in sequence. See, when I'm teaching something, I'm teaching it in order, right? If I teach something, if I teach RNNs first and then go back to LSTM and then transformers and then ANN, will you understand anything? There's a sequence, right? First we teach machine learning, we teach deep learning, and then we start with what? In deep learning, ANN model, CNN, and then RNN. We require sequence, right? So this is text being processed sequentially. Okay? Text summarization, language translation. So all these are chatbots. Okay? Chat GPT that we use. All these models are sequential models because they process the data and understand the data in sequence. Okay, and voice again, voice data. So you're understanding me because I'm talking it in sequence and I'm putting proper English sentences such that it is easy for you to access and understand, right? So RNN models are the only neural network models which process the data in what? Sequence. So three different types of sequence data as I was talking about: numerical sequence, textual sequence data, and then voice or speech sequence data. So obviously the voice, language, all these are complicated things, right? How many languages are there in the world? We ourselves don't know, but we want machine to learn all languages and reply back in the machine translation, which we use in Google. I type something and say, generate it in some native African language, it will do that job. Okay, so we are so advanced that language translation works properly where we doesn't know how many languages in the world exist, but we want Telugu to some African language translation, it is able to do it properly because of all thanks to what? The transformers and RNNs. Okay, so language processing is a very complicated task. So that is the reason only on RNNs, advanced RNN models, LLMs and all that would be discussed in this semester. Same again, loss function, forward, backward would be there for any model. That is the reason we are doing this recap or revision today. Okay, so please make sure that you understand completely clearly about ANN today in the class. CNN not required. CNN is same like ANN where only image would be changed. Okay, we will not focus on CNN in this semester. So we will recap only ANN. Again, I'll brush up the steps. Please work on the exercise. Don't open ChatGPT and ask XOR gate ANN from scratch code. So we want you to sit and work for yourself, not for ChatGPT or not for us, such that you'll understand how do we develop. Okay. Yeah, all these things we have seen. Yeah. So this was the main architecture. Okay. So what do you observe in this architecture? This architecture is for what? ANN. So what do you observe in this? So we have input layer with x1, x2, where you can take it as XOR gate. Okay. And then I have one output, which would be one output of the XOR gate. I have taken two hidden layers, where first hidden layer will have ReLU, second hidden layer will have sigmoid, which is connected to output. I go for forward propagation. I calculate loss, which is nothing but the difference between actual value and predicted value. I'll go for what? Backward propagation. Okay. So I will not focus much on images. Yeah. So how do we build artificial neural networks? These are the steps. I'll quickly recap steps for you to work on XOR gate exercise. What do we do first? I import libraries, read the data set, you forget about all that. First we have to initialize what? The network architecture. What do you mean by initializing the network architecture? How many input layers, how many hidden layers, how many output layers? That is Z1, A1. What is this Z1? What is Z1? WX1 plus B. What is A1? Activation function applied on Z1. See, we will use the same terminology till we die if you are working on ANN. So don't forget these things. What is Z1? Transfer function of input with weights added in first hidden layer. What is A1? Activation function applied on Z1. If I take only one layer, this would be thin. But if I take two layers, I have Z2, which is connection between hidden to first hidden layer to second hidden layer. I'm talking about second hidden layer. Understand, please. I know you forgot everything. Let me recap. This is my network. How many input layers are there? I'm not asking you neurons. I'm asking you how many input layers. How many input layers? Only one. How many neurons in the input layers? Two. Because I want to design XOR gate which has A, B as inputs or X1, X2 as inputs. So only one input layer with what? Two neurons. Now I want to connect this input layer to hidden layer. First hidden layer. How do I do that? With Z1. With what? Z1. Z1 is what? WX plus B. I am forming a channel where it connects input layer to hidden layer. That is called as the transfer function. Transfer function which is nothing but Z, which is WX plus B. After this, I'll apply activation function to this, which is ReLU, which is called as A1. Now I formed the connection between input to hidden one. I also have what? Hidden 2. Now I'll apply Z2. Z2 is what? A1, A1 x plus b. Is it clear? This is how I form connection between hidden 1 and hidden 2. And then finally from hidden 2 to output. Is it clear, everybody? Okay. Yeah. So first we initialize the networks. When I talk about initializing networks, telling Z1, A1, Z2, A2. How do I generate weights and biases? I generate weights by using random function. I generate bias by using zeros from NumPy. Okay, that you remember, I'm glad. Next, after that we can do what? Define the activation functions. After that, we do forward propagation where we apply the connections together, and then we define loss function. After loss function, we go for backward propagation, and then in backward propagation, we use different optimizers. Use only gradient descent. Don't go for anything else. We'll use only gradient descent and try to optimize the weights, and then we'll train the network, putting it all together in sequence and all that. Okay. Now this is most important thing. What do you observe here? Now we have developed a neural network with the following steps. Now I want you to understand how the core components affects the performance. When I talk about core components, I talk about activation functions. I told you, apply ReLU in the hidden layer, check for the performance. Apply sigmoid in the hidden layer and check for the performance. Okay, this is first point. Second point, loss functions. I can't use MSE when I talk about classification. I can't use binary cross entropy when I talk about regression. So you have to be very specific about the problem statement. You have to be very specific about the data. Now for XOR gate, what loss function do I have to use? Binary cross entropy. Because in XOR gate I have 0 or 1 as my output, which is binary output. So I use what? Binary cross entropy. Okay. And then optimizers. So we have Adam optimizer, we have gradient descent, but for now let's use only Adam. Let's use only gradient descent. Okay. So how activation functions will differ, how loss functions, as I was talking about, we have MSE for regression, binary cross entropy, categorical cross entropy, and then we have different types of optimizers, stochastic gradient descent, Adam, okay, RMS prompt, SGT and all that. Okay. Are you clear with this? Okay. So I will just switch on to the exercise part. I'll quickly explain you the code also. Okay. Yeah. So what is our exercise? Please read that. All of you are supposed to develop a ANN model from scratch. For what? For XOR gate. Why am I calling it as XOR classification? Because XOR gate is a classification task because the outputs are categorical values 0 and 1. Okay. With a 2-layer ANN. What am I asking you? Okka layer gaadu. 2 layer in the sense 2 hidden layers. So my architecture would be one input layer with 2 neurons. How many input layers? 1. How many input layers? 1. With how many neurons? 2. Why? Because XOR gate is a basic 2 input XOR gate. So I have 2 inputs, so 2 neurons in the input gate. How many hidden layers? 2 layers in the hidden gate, hidden layers, and then 1 output layer with how many neurons? Only 1. It will either be 0 or it will be 1. Ardhamaina ippudu architecture? 1 input layer, 2 hidden layers, 1 output layer. Input layer will have 2 neurons, output layer will have 1 neuron. Hidden layers will be automatically calculated based on what you take in the inputs. Okay? Yeah, look at that. So implement a 2-layer ANN to classify the XOR problem using NumPy. Only NumPy. Okay? Input layer, yeah, that's what I have told. Yeah. So what is first thing? You have to import libraries. What libraries you want? Do I need train test split here? I am not splitting any data, so I don't need train test split. Only NumPy. I am not downloading any data from sklearn, so I don't need sklearn also. Only import NumPy as NP, your first line of the code. At least do this, those who doesn't know anything. Okay. Next. After that, defining the XOR gate. So that is the XOR gate. Those who doesn't know anything, please at least listen to this. 0, 0 is 0, 1, 1 is 1, 0, 1, 1, 0 would be 1. So that is the XOR gate. So define the data set. First, import the libraries. Second, define the data set. Third, initialize the weights and biases. I want W1, W2 here, B1, B2 because I have 2 layers. Okay? np.array, I am creating a list of array. Okay? And then I am initializing weights and biases with W1, B1, W2, B2. Okay? So why am I taking random.random 2, 2? 2 layers. Okay? 2 neurons in that. And then second time I have W2 connected only to the output. So I have 2, 1. Listen. 2 neurons in the input, 2 neurons in the output. Hence for W1 I write 2, 2. Second hidden is connected to output where it has only 1 neuron. Hence I could keep it as what? 2, 1. Okay, I am done now. Okay. Next is what? See, cheyandi. Try cheyandi. If you get doubt, we'll come and solve it. Madam, I am getting error here. Please solve me. So that is how we work. Okay. Don't copy paste from your friends. Me kosam meer cheyandi. That is what I am telling you. Okay. Second is what? Define activation functions. So we'll use 2 activation functions. ReLU and sigmoid. ReLU for the hidden layer. Sigmoid for the output in first exercise. Second exercise, sigmoid in the hidden, sigmoid in the output. Why sigmoid in the output, by the way? Because it is a binary classification task. ReLU, sigmoid. 1 second glance. ReLU is 1 by 1 plus e power minus x. Okay, sorry. Maximum of 0, x. Sigmoid is 1 by 1 plus e power minus x. Done. Okay. Next is what? Define hyperparameters. So for the initial exercise, we are defining only 2 hyperparameters. What are they? Learning rate and number of epochs. So what is the default learning rate? 0.01. Epochs, that is your wish. Number of epochs you take. Okay. Done. Next is what? Next is what? Training loop. Forward propagation, loss calculation, backward propagation. Okay. I'll also just display this for a second. Okay. Yeah. See, I am not defining separate activation functions, separate all that. In the training loop itself, I am defining them because I don't want to complicate the task. It's a very simple task with simple data set, so I am doing this. Okay. Now look at this. For epochs, listen to this, I'll explain this line by line. For epochs in range, that epochs is what? 5,000 which I've designed. I told you, right? Even if I take 5,000, 20,000, I am not getting any difference. And you will have to check that. Okay? So I am going for forward propagation first, where I'll define what? Z1, A1, Z2, A2. What is Z1? NP dot product of X, W1. Input into the first weights. What is A1? ReLU of Z1. What is Z2? NP dot product of what? A1, W2, the new weights generated. A2 is nothing but the sigmoid. So I am applying ReLU in the hidden layer, sigmoid in the output layer and forward propagating. After that, I will go for binary cross entropy loss calculation and you know the formulae. Okay. After that, I am going for what? Backward propagation. What are the 5 parameters for backward propagation? dz2, derivative of loss with respect to z2, that is dz2. I want to change w2 and b2. So we calculate derivatives of weights, w2, derivative of bias b2. After that, derivative of a1. After that, derivative of z1, derivative of w1, b1 in the backward way. dz2, dw2, db2, da1, dw1, db1 and so on. Okay. After that, once I go for backward propagation, my weights would be changed. I have to update the weights. The old weights are W2. I am updating with respect to learning rate. So the new weights, new weight W2 is equal to what? Learning rate into derivative of that dW2. And then finally I want to print the number of epochs. Is that clear? For I in range of epochs, I'll first apply forward propagation. I'll calculate loss. I'll calculate the gradients in the backward propagation. I'll update the parameters and I will print the number of epochs. Okay. After that, what do? we test the model. Okay. So how do I test the model? By giving what? By applying what? 0 0 combination, 0 1 combination, 1 0 combination, 1 1 combination. I check my out. Now I'll show you the results. Look at this. I'll show you the results later. Okay. Now look at that. What is your exercise? Second exercise. Same code, but what are you supposed to do? Compare the performance of different activation functions. What is that? ReLU and sigmoid. Now look at the explanation. Training loss convergence rate. What are you supposed to do? You have to calculate loss convergence rate when you put ReLU in the hidden layer, when you put sigmoid in the hidden layers. And then you also have to you have to check for final accuracy, whether you find any improvement or not. So even in this case, you don't see, So after you define your activation functions, please put this code. So what I'm trying to do is, I am putting hidden activation function is equal to ReLU, or you can change that to sigmoid. So I'm just putting one loop, if and elif loop. So if I put ReLU there, the ReLU will be taken into consideration. If I put sigmoid will be considered. Okay. So in the same code, you can just add this block of code where it works for both the cases. Okay. Now look at this. What do you observe here? Look at the first thing where I've taken ReLU in the hidden layer. Look at that loss. First it was 0.692. Second it is 0.6265, 0.4854, 0.4801. So is the loss being gradually reduced? Yes. Look at sigmoid used in the activation hidden layers. Do you find any change in the loss convergence? Okay. So read this please. Read this please. So when I talk about ReLU, the loss convergence started 0.6932 and then it gradually reduces till what? 0.477, which means that the model is effectively learning because the loss is being gradually minimized. Is that clear everybody? Yes or no? Next, in case of sigmoid, there's no change. Okay. Now, why ReLU outperforms? Now, this is the answer that I want from you, so I won't show this. Why is ReLU outperforming sigmoid? Why is that loss convergence good for ReLU but not for sigmoid is what you have to give me the answer. Okay. Next. What is your third task? Design and implement the neural network to solve the XOR problem with improved accuracy of what? 80 to 90. In the previous case, the loss was 60 or 40, which means that accuracy is around 50 to 53. But you are supposed to improve the accuracy of the model by doing what? Look at those tasks. First, you have to create the network that you will do. Second is, instead of ReLU, use what? Leaky ReLU. There is another activation function called, in appudu cheppanu brief guy, I also told you, don't worry about this now, we'll talk about it later. That later is today. Okay. So understand what is leaky ReLU, how is that different from the normal ReLU, and how is the functionality getting differed. Okay. Next one, use sigmoid for the output layer. There is another thing called as he-initialization. Please understand this. This will be very useful for you when you work on attentions and transformers. Okay. Listen. Do we have the flexibility of changing the number of neurons in the hidden layers? It automatically gets calculated depending on input and output, right? But we also have this flexibility using this concept which is called as what? He-initialization. Do this or not, that doesn't matter, but I want you to understand that there is something called he-initialization which will allow us to change the number of neurons in the hidden layers such that we will have better convergence. Better convergence in the end, loss being gradually reduced such that my accuracy will be improved. Okay. Apply binary cross entropy and then check for the output. So in the third exercise, what are we doing? Change learning rate. Instead of ReLU, apply what? Leaky ReLU and then check for the output. Is it clear everybody? Chalo, start working on the exercise. No mobile phones, no Wi-Fi getting connected, no ChatGPT. If we find ChatGPT, you will be out of the PS batch only, not today's session or something like that. Is that clear? So Priyanka madam is here, I am there, we are monitoring you. No ChatGPT, no other window, sit and develop everything from scratch. If you have doubts, you call us, we will be happy to explain you. Is that clear everybody?
2 neurons in hidden to only 1 neuron in the output. Okay, please make sure about it. Okay. So what is np dot zeros of 1 comma 2? Only one bias term in the first hidden layer and second hidden layer. Okay. So this is how I import my NumPy library. I create the data set and initialize weights and biases. The first 3 steps. Just have a glance. We'll switch back to the next one if you didn't do this part. So make sure about that 2 comma 2, 1 comma 2, 1 comma 1 and all that. You understand why am I taking them like that? W1, W2, B1 and B2. Okay? Now once I am done with this, we'll define the activation functions. For ReLU, what is the formula? Max of 0, comma x. Okay? So refine ReLU and the derivative of ReLU. Refine sigmoid, derivative of sigmoid. Okay? For the sigmoid, the formula is 1 by 1 plus e power minus x. Okay? The same thing I am doing there. So define ReLU of x where x is the input and I want to return np dot maximum of 0, comma x. How I calculate the derivative? Return x greater than 0, float type. Okay? Complete till this.